Hi, today we're going to be looking at the development of the distance formula. So we're going to start with this triangle and then put it on the grid just to make things a little bit easier for us to do some counting, etc. So just for fun, let's say I want to find the length of this, the hypotenuse here of this right triangle. Okay, so we have this right triangle and did that right? There we go. So it's a right triangle. And I want to find the length of the hypotenuse, and I know I like to use L squared equals S squared plus M squared, meaning the length of the long side squared, or sorry, the area of the square off the hypotenuse, the longest side, is equal to the area of the smallest square plus the area of the medium square, i.e. the two squares that are off the medium or the small leg and the square that's off the medium leg. Okay, I have a couple videos that outline the Pythagorean theorem very well, so please go and take a look at those if you need a little refresher. And so I use L, S, and M as opposed to A, B, and C because A, B, and C, in my opinion, that's very humble opinion, don't mean anything as much as L, S, and M do. Anyway, so I'm trying to find the length of the hypotenuse here, which is the length of the longest side of this triangle. And let's just say that these units are two units apart, these markings. So we've got 2, 4, 6, 8, 10, 12. So we've got 12 units here. Then we've got 2, 4.5. So that would be 5. There's still not 4.5, 5 units there. And I need to find this length here. So if I put it into this formula, L squared, S squared is 5 squared, M is 12, and that's squared that, so we get 25 plus 144, and that gives me 169. Therefore, this is all L squared. And then L, I take the square root of both sides, and the square root of 169 is 13. Okay, so that's all fine and dandy. Now, if I were to find the slope or the gradient of this line as well, just for fun, the gradient of this we know as rise over run. And the rise of this triangle is 5 units, and the run is 12 units. So I'm taking the length from here to here for the run, and I'm taking the rise from here to here, or the length for the rise, and that gives me 5 over 12. Okay, so I'm going to go to the next triangle here, and here I've got, it's on the grid, and now we've got values, the scale on here, on the axes. And if we look at the run again, so the run goes from here to here, and the run, I see, well, the x value of that run of the first point is 12, and the x value of the second point is 24. So if I did 24 minus 12, because it's being measured from the origin, so it's 24 all the way to here, and it's 12 units all the way to here, so the difference between them would be 12. And then if I did the same thing here, the rise is, well, here the y value here is 6, and the y value up here is 11. So I'm doing 11 minus 6, and that gives me 5, okay, for that rise. And so then if I notice this 24, that is this x value right here. That's x2, because that's from point 2. And this 12 is from x1, which is from point 1. So I see actually here that this is actually x2 minus x1. And the y values, I've got 11 minus 6. Well, here this is y2, and this y value is y1. And so 11 minus 6 is actually y2 minus y1. And that's how we actually get the 12 for the run and the 5 for the rise. And so then if we're going to find the distance, well, the distance is actually, we saw before that it was s squared plus m squared. And so s squared is actually 5, but that 5 actually came from 11 minus 6 squared. And this m is 12, but it came from 24 minus 12 squared. And that 11 was actually y2, and the 6 is actually y1. And then here for the 24, that 24 is x2, and the 12 is actually x1. So the distance formula is actually nothing more than, and I'll just scroll up a little bit here, the different distance formula in general. If I take the square root of both sides, and distance, well, L, I'm going to actually change that now to a D for the distance formula. So the distance between these 2 points, 2411 and 126, is actually no more than the sum of the rise, or sorry, the rise squared and the run squared. So we can actually take that, and it's the square root of that because we took the square root at the end. So this is more or less a combination of Pythagorean theorem with the slope formula. And remember that the slope formula that we saw on the other side was rise over run. And if we were to use coordinates now in points, and sorry, actually these should be in brackets for these points. This is actually delta y, so the rise is delta y, and the run is delta x, and the change in y is actually the difference between the two y values, so y2 minus y1, and the delta x is the difference in the two x values, x2 minus x1, and this is what we have right over here. We've got y2 minus y1, and we've got y2 minus y1, and then here we've got x2 minus x1, and here we have x2 minus x1. So if we were to find the slope or the gradient of a line segment between 2 points, we would take the y values and subtract them. We would take the x values and subtract them, and then we get the ratio of that. That would give us the gradient of that line segment. And if we were then to square those differences that we have from here, if we were to square these differences, let's say this is delta y squared over delta x squared. If we square those actually come as these two differences in the distance formula. So, and the distance formula is actually nothing more than Pythagorean theorem. Usually it's written, I'll just tidy this up just a touch. Usually we see this written as d is the square root of, and then they put the x's first. X2 minus x1 all squared minus y2 minus y1 all squared, and it's the square root of all that. Okay, so that's where the distance formula actually comes from. A combination of gradient or slope with the difference in the coordinates, and more importantly, from Pythagorean theorem. So thanks for watching, and we'll see you in the next video.